Okay, hi students. So today I want to explain about the Boolean algebra. Okay, Boolean rules and Boolean algebra. So where we are using this Boolean algebra, so that means the Boolean algebra is nothing but it consists of like variables A, B, C, D, or X, Y, Z. Okay, and with zeros and ones. So in order to minimize the given expression into minimum number of variables, we'll use this Boolean algebra. So before minimizing the Boolean expressions, we need to follow some laws. Those are nothing but Boolean laws or Boolean rules. Okay, so first we'll see and law. Okay, and law. So what is this and law? You know the like truth table for this AND gate. A, B, and output is Y. So that means if any of the input is 0, the output is 0. If both inputs are 1, the output is 1. Okay. So that is the definition of AND gate. So if any of the input is 0, the output is 0. And both inputs are 1, the output is 1. Okay. So first law. So first law, if you take A and A equal to what? A. Okay. A and A equal to what? A. So A and A equal to A means I can take this one and this one. Okay, this is first law. So you see here. So that means A is 0 and 0. That is equal to what? 0. And A is 1 and 1. This is equal to what? 1. So A and A equal to what? A. Okay. And next A and 0 equal to what? 0. Okay. So A and 0 equal to 0 means so you can take which one and which one. So A and 0 equal to 0 means you can take first one and third one. Okay. So this is second law. So that means A is 0 ending with 0. This is equal to what you are getting? 0. A is 1 ending with 0. You are getting 0. Okay. And so this is A and 0 equal to 0. Third law, if you say, so third law, A and 1 equal to A. A and 1 equal to A. So A and 1 equal to A means you can take this second one and fourth one. Okay. This is third law. So A and 1 equal to A means if A is 0 ending with 1, what you are getting? 0. Okay. And A is 1 ending with 1, what you are getting? 1. Okay. And fourth law, if you take, so fourth law is A and A bar equal to 0. Okay. So A and A bar equal to 0 means so this one so complement of this one. No? So these two you can take. Okay. So A is 0, complement of A is nothing but 1. So this is equal to 0. A 0 and A is 1, complement of this one is 0. You are getting 0. Okay. So this is nothing but AND law. Okay. AND gate. Okay. AND law. Okay. And next we'll see by using OR gate, we'll use OR law. OR law. Okay. So you know the truth table of OR gate, A, B, and output Y, 0, 0, 0, 1, 1, 0, 1, 1. Okay, so that means if any of the input is 1, the output is 1, and both inputs are 0, the output is 0. Okay, so by using this truth table, I'm going to prove this OR laws. Okay, so what is my first law? A or A equal to what? A itself. Okay, A or A equal to what? A itself. Okay, so what I can take? So A is 0 with A. Okay, so this is first law. So that means 0 or 0 equal to what? 0. 1 or 1 equal to what? 1. Okay, and next if you take next A or 0, A or 0 equal to what? A. A or 0 equal to what? A. So A or 0 equal to A means you can take this first one and third one. Okay, this is second law. So that means A is 0 with 0 equal to what? 0. You are getting A itself. And 1 or 0 equal to what? You are getting A is 1. So that means you are getting 1 itself. Okay. And next third one if you take, A or 1 equal to 1. So A or 1 equal to 1 means you can take A or 1 equal to 1. So this one and this one you can take. Second one and fourth one you can take. Is third law. And 0 or 1 equal to what? 0 or 1 equal to 1. And 1 or 1 equal to what? 1. Okay. 1 or 1 equal to what? 1. Okay. And fourth law if you take, A or A bar equal to what? A or A bar equal to 1. Okay. A or A bar equal to 1. So that means what I can take, A and A bar equal to 1. So this one and this one I can take. So A is 0, complement of this one, that is 1, equal to what? 1. A is 1, complement of this one, that is 0, equal to what? 1. Okay. So these are the some OR laws. Okay. So that means A or A equal to A or 0 equal to A or 1 equal to 1, and A or A bar equal to 1. So I proved with this truth table. Okay. And next NOT law. So what is this NOT law? NOT law. NOT law means you know the truth table for NOT gate. I think so. So that means y. If it is 0, it is 1. If it is 1, it is 0. Okay. So that means A bar whole bar equal to what? A. A bar whole bar equal to what? A. Okay. This is about this. And next commutative law. Commutative law. So commutative law. So A or B equal to what? B or A. Okay. Dual of this one. That means A and B equal to what? B and A. This is commutative law. Okay. Commutative law. And next you have associative law. Associative law. Associative law means here you can remember associative law is nothing but same like A or B or C. So you have same OR gates here. Same OR gates. So this is nothing but A or B or C. Okay. A or B or C. Okay. Or A and B and C equal to what? A and B and C. Okay. This is associative law. Okay. And next distributive law. distributive law. For distributive law, so distributive law means you can understand this is a difference. Okay, so that means A and B or C equal to what? Equal to A and B or A and C. Okay. So dual of this one means and will change to R will change to and. So you can write A or B and C equal to what? A or B and A or C. Okay. A or C. So from the distributive law, so this is one important law, distributive law. You'll get one more law like you can call as absorption law. Absorption law. So absorption law is A or A bar B. Okay, A or A bar B equal to. So if I apply distributive law, what I am getting? A or A bar, A or B. Okay. So anyway, from R law, A or A bar equal to what? 1. A or B. Okay. So this is A or B. From AND law, A and 1 equal to what? A. A and 1 equal to what? A. Okay. And next, so that means here A or A bar B equal to A or B. Okay. And next, one more that is A bar or AB. So you have true form and complemented form. So this becomes the redundant. Okay. And here also complemented form and true form. So if you expand, what you are getting? A bar or A, next to A bar or B. So this is 1 and A bar or B. So this is A bar or B. A bar or B. Okay. So this is about commutative law, associative law, distributive law, and from the distributive law, if you apply, you will get absorption law. Okay. And next we will see DeMorgan's law. DeMorgan's law. So what is the DeMorgan's law? A or B whole bar equal to A bar and B bar. So that means R will change to and a complement. So this whole complement equal to complement will come to each and every variable. Okay. So and one more law. So that is A and B whole bar equal to what? A bar or B bar. Okay, A bar or B bar. So and whole complement equal to what? Complement will come to each and every literal, and so and will change to R. Okay, so this is DeMorgan's law. So I can draw the diagram like this is nothing but uh, NOR gate. This is NOR gate. So that means A, B. Here you are getting A or B. Okay, from this you can, this is equivalent to what? This is equivalent to bubbled and A bar and B bar. No? So next NAND gate. NAND gate. So this is A, B, A and B whole bar. This is equivalent to what? This is equivalent to bubbled R. Bubbled R. Okay. So this equivalency we are going to use in the realization of Boolean expressions by using only NAND gates and NOR gates. So this you need to remember. Means these equivalency of gates you need to remember. Okay. So this is about DeMorgan's law. Okay. So we already seen this all these laws, and one more theorem is there. That is consensus theorem. consensus theorem. So what is this consensus theorem? AB or A bar C plus BC equal to what? AB or A bar C. Okay. So that means here all the variables should be present in the LHS. Okay. All the variables should be present in the equation, and one variable is complement of other variable, and these two variables are repeated. Okay. So that means this becomes the redundant. This becomes the redundant. So that means AB. So AB or A bar C plus BC, you can write as AB or A bar C. Okay. And what is the dual of this one? So just and will change to R and R will change to and. Okay. So this is A bar C and B or C. This is equal to what? A or B and A bar or C. Okay. So suppose if I want to prove this one. Okay. If I want to prove this one, how I can prove? Take LHS. Take LHS. So what is LHS? AB or A bar C or BC. Okay. Here I can write 1. Okay. So that means from AND law, you know that A and 1 equal to what? A, no? So I added 1. So AB or A bar C or this I can write as A or A bar. Okay. And BC. Okay. This one I'm writing like this. Why? Because from R law, you know that A or A bar equal to what? 1. Okay. So if you write this is AB or A bar C or ABC or A bar BC. Okay. So if you combine these two, what you can take common? I think you can take AB common. So this is what? 1 plus C. Okay. Plus from these two, what you can take common? A bar C I can take common. So this is what? 1 plus uh, 1 plus C. 1 plus C. Okay. So AB if you take common from these two, you are getting A bar C. So 1 plus C. So what you are getting? So that means AB and 1 or A bar C and 1. Okay. So you know that A plus 1 or A or 1 equal to what? 1. Okay. And next, this you can write as AB or A bar C. Okay. So this is equal to what? RHS. Since you know that A and 1 equal to what? A. Okay. A and 1 equal to A. Okay. So this is how you need to do the this one. Okay. Consensus theorem. To proving this consensus theorem. Okay. So we'll see some problems related to this Boolean algebra. Okay. So how we are applying this Boolean laws into this. Okay. So first problem we'll see. First problem, AB bar or A bar or AB whole bar. Okay. So you need to minimize the given expression to minimum number of variables. Okay. So here you can consider x equal to what? AB. X equal to AB. So if you consider x equal to AB, so what you will get? X bar or A bar or X whole bar. Okay. So that means you know from R law, A or A bar equal to what? 1. Okay. So that means 1 or, so this you can write as 1. Okay. 1 or A bar whole bar. So from this, you know from R law, A or 1 equal to what? 1. So this is 1 bar. Okay. So 1 bar. So this is equal to what? 0. Okay. So this is equal to 0. Okay. So like this you need to do. Okay. And next we will see. Let us take this expression. This second one. Okay. AB bar or and C or BD or A bar B bar. Okay, this you need to minimize the given expression into minimum number of literals. Okay, first what I can do, this is you can multiply. So this is AB bar C or ABD or A bar B bar. Okay, okay, AB bar. One second. Here the AB bar, and this one is BD. Okay, BD. So what is this one? This is nothing but what? 0. Why? Because you know from AND law, A and A bar equal to what? 0. Okay. So that means AB bar C or 0 or A bar B bar. Okay. So this is equal to what? So from this, what you can take common? I can take B common. Okay. One more step I will write. So that means AB bar C or A bar B bar. So since we know that A or 0 equal to what? A. Okay. So here, if you take B bar common, what you are getting? AC or A bar. AC or A bar. Okay. And from the absorption law, by using distribution law, you know that A bar or AB equal to what? A bar or B. Okay. So this is equal to what? B bar, A bar or C. So A is the redundant. Okay. So still it will not minimize. So this is the final answer. Final answer. Okay. Next third one we will see. Third one, A B C whole bar, A bar, A or B or C whole bar, A or B or C whole bar. So you need to apply the DeMorgan's law. So if you apply the DeMorgan's law, what you are getting? A bar or B bar or C bar, B bar. Here this is A bar, B bar, C bar. So just AND will change to OR and OR will change to AND, and the complement will come to each and every variable. Okay. So next you multiply. So this is A bar, B bar, C, and next B bar, A bar, B bar, C. Next C bar, A bar, B bar, C, C bar. Okay. So you know that A and A equal to what? A. Okay. So that means you can write A bar, B bar, C bar. A bar and A bar equal to A bar I am writing, and B bar and B bar equal to what I am writing one time. Okay, B bar, C bar, and here also C bar and C bar I can write one time C bar. So A bar, B bar, C bar. Okay. So here what we are getting? So that means this is equal to what? A bar, B bar, C bar. Since we know that A or A equal to what? A. Okay. So same terms are there. So I can write this is the minimum given expression into minimum number of literals. Okay. Fourth one is fourth one I will see. So this is A or B bar C or A or B bar C whole bar. Okay, so I need to apply the DeMorgan's law for this one. Okay, so for first you need to apply the DeMorgan's law. So when you apply, what you are getting, A or B bar C, A or B bar whole bar or C bar. Okay, so B bar whole bar or C bar. Okay, so that means A or B bar C. So since we know that from DeMorgan's law, AB whole bar equal to what? A bar or B bar. So this law applied, or B or C bar. Since we know that from not law, A bar whole bar equal to what? A. Okay. So next what you can do? You can multiply. So A or B bar C A or B bar C B or B bar C bar. Okay. So anyway, these two, so that means this is anyway 0, and due to these two, this is anyway 0. Why? Because you know that from AND law, A and A bar equal to what? 0. Okay. So that means A or B bar C A or 0 or 0. Okay. So you will get A or B bar C A. Since you know that A or 0 equal to what? A. Okay. And what you can take common? A you can take common. If you take A common, what you are getting? 1 plus B bar C. Okay. So this is A and 1. Since we know that A or 1 equal to what? 1. Okay. So that means you can consider this as X. So A or 1 equal to 1. Again, this is equal to what? A. Since we know that from AND law, A and 1 equal to what? A. A and 1 equal to A. So this is, so you minimize the given expression into minimum number of literals. Okay. So minimum number of literals. Okay. Uh, Next we'll see, like he given one problem. If x equal to, let us take x equal to 1 in the logic equation, in the logic equation, okay, logic equation, x plus z into y bar or z bar or x y bar and x bar or z bar x or y equal to 1. Then what is the value of z? Okay. So if you apply x equal to 1 in this above expression, 1 or z y bar or z bar or y bar. Okay. And next here, this is one nothing but 0. 0 or z bar 1 or y. 1 or y. This is equal to what? 1. Okay. So anyway, this is what 1 and something. This is something. Let us take x. So you know that AR1 equal to what? 1. Okay. So that is this is 1, and you know that AR0 equal to what? A. Okay. So you are getting Z bar, and from this AR1 equal to what? 1. So dot 1. Okay. So this is equal to what? 1. And Z bar equal to what? 1. Since A and 1 equal to what? A. Okay. So that means Z equal to what? So 0. Z equal to 0. So like this you need to do. Okay, and next we'll see. One second. Next you see. So if the expression is given, like second one we'll see. So if you have three variables A, B, and C, okay, find the output Y. Find the output Y equal to 1 for the majority of ones, ones in ABC, okay. Also minimize the expression. Also minimize the expression. So if you take like, if that means here three variables are there. How many combinations you have? You have 8 combinations. So that means A, B, and C. Okay. So if you take the output Y, so how many combinations? 8 combinations. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So majority of ones are 1. So that means 2 ones are 1. The output is 1. Or at least 3 ones are 1. So at least 2 ones are 1. The output is 1. Okay. So only 1 is 1 means the output is 0. Output is 0. Okay. So that means I can write the expression. This is nothing but what? A bar BC. This is A B bar C. This is A B C bar, and this is A B C. Okay. So if I write the expression y equal to what? A bar B C or A B bar C or A B C bar or A B C. Okay, A B C. So so what I can do? So from this, what you can take common? A bar. So from these two, what you can take common? From these two, what you can take common? A bar B C, A bar B C, A B bar C. Okay. From these two, first I will take common. So from these two, A bar B C or A B bar C. If I take A B common, I'm getting C bar or C. Okay. So y equal to A bar B C or A B bar C, A B and 1 I can take. Means A or A bar equal to what? 1. So next, so next, from these two, what you can take common? From these two, if I take A common, what I am getting? A common. So y equal to A bar BC. If I take E common, I am getting B bar C, B bar C or B, B bar C or D. Okay. So we know the law, that is A or A bar B equal to what? A or B. So y equal to A bar B C or A common. So this you can write as B or C. B or C. Okay. Next, y equal to A bar B C. This is A B or A C. So from these two, what we can take common? So you can take B common. So if you take B common, what you are getting? Y equal to B common. So A bar C or A bar C or you take B common A. okay, or AC, okay. So that means I can write this one as y equal to, so from this law, okay, it is like this law, a bar b equal to a or b. So I can write b or a or c plus AC, okay. So y equal to what? Y equal to AB or BC or AC. So we will get this expression. So this is like what, 2 out of 3 logic, no? So that means majority of, at least majority of ones are 1, means we are getting output at 1, or otherwise output as 0. Okay, so this is about the Boolean algebra, and we already seen the what are the Boolean laws. Okay, so first we have seen the AND law, OR law, and commutative, associative, distributive. And distributive will get absorption law and DeMorgan's law. And next we have seen the consensus theorem. So we have proved the consensus theorem. And next we have seen some problems related to this Boolean laws. Okay, I hope you understand this lecture. Okay, so thank you.